Group 10 was tasked with the project of designing a warehouse model for a client based in Wollongong, New South Wales, using 3D structural modelling programs Revit and SpaceGas. The client briefing requested a warehouse with a portal frame span of 20 metres and a width of 20 metres, as well as an eave height of 10 metres. The rafters were required to withstand a load of 8 kilonewtons, whilst also having a roof set at a 6-degree angle. The whole warehouse is going to sit on a 400mm concrete slab with a 200mm overhang from the warehouse's border. It was also requested that the warehouse should hold a minimum of 10 windows and 2 doors, as well as a mezzanine to allow for more working space inside. With a building length of 20 metres, our warehouse design allows for 4 bays with 5 portal frames spaced at 5,000mm. The 10-metre eave height gave space for 7 girts spaced at 1,583mm, and each roof slope has room for 7 purlins spaced at 1,424mm.
The incorporation of the mezzanine level to add usable internal space was modelled as a simply supported steel frame platform connected to the main columns. It used rolled steel joints and metal decking designed to meet both strength and deflection limits under live loading.
The framing columns used in the warehouse are steel universal beams selected for their rigidity and structural properties, and the rafters used in the roof were also steel universal beams, chosen for their load-bearing capacities. For our purlins, we selected light-gauge Z-beams to hold the roof, as well as using light-gauge lip channels as our girts. These components use minimum material while still providing strong structural support.
In terms of facade detailing, the structure includes multiple doors and window openings. The southern wall has 15 910 by 1210mm windows, and the north wall has 6 larger 1810 by 1210 windows. Roller and sliding doors were added to the front and the rear elevations for access. Secondly, framing was used all around the openings to distribute loads evenly and maintain wall stiffness.
As outlined by the client, the selected wall cladding was 42mm spandeck, chosen for durability and flexibility. The roof also uses Lysat Cliplock Classic 700 sheeting, taking into consideration the purlin spacing and factors such as water catchment and weather conditions. Using SpaceGas, we were able to analyse the structure, following closely along with Australian standards. In accordance with AS 1170, our warehouse has been analysed under the A2 region, which is representative of wind conditions in the Illawarra.
Once the model was established, we applied 5 primary load cases in accordance with AS 1170. Dead load, live load, internal and external crosswind, and internal longitudinal wind. These loads were then combined into serviceability and ultimate limit states to evaluate the frame's structural performance under realistic conditions. Then, the loads were applied to a 2D frame to assess bending moments, shear forces, and deflections. This methodology ensures that at every stage of the design, from geometry and loading to material selection and code compliance, both the brief and Australian engineering standards are reflected. Special attention was given to the connections as they are critical for the portal frame's overall rigidity and load transfer. There were 3 key connections that were used in the design, including the apex joint, rafter to column knee joint, and the column to base plate connection. Each connection was checked in SpaceGas for strength, stiffness, rotational capacity, and then verified for stability using IG Statica.